Welcome to 9.7, the cross product. Our objectives are find the cross product of two vectors, know algebraic properties of the cross product, know geometric properties of the cross product, find a vector orthogonal to two given vectors, and find the area of a parallelogram. So, our cross product is different than our dot product in that we are finding not just if it's orthogonal anymore. This is giving us more information between these two vectors. Our algebraic process for finding the cross product involves something called our determinant, which I expect you have read about, and we're going to be using it today in all of the examples that find cross products. We're given two vectors. V is 3i plus 2j minus 4k, and w is I minus 3j minus k. We want to find v cross w. So the first thing I'm going to do is I'm going to set this up with a matrix. I, j, k. And then I'm going to put v because I'm doing v cross w. So v is three I, 2j, negative 4k. W is 1i minus 3j minus 1k. So, if I want to take my cross product, first I will do I, and then when I look at I, I'm looking at what's left if I don't use anything in the row or column of I. So that will be the determinant of 2, negative 4, negative 3, and negative 1. And then I'm going to subtract j. And j is looking at these. So anything that's not in the row or column of j, determinant of 3, negative 4, 1, negative 1. And add k, which will give us these right here. So the determinant of 3, 2, 1, negative 3. And in order to find the determinant of each of these, we do I times, so we are going to have 2 times negative 1 minus negative 4 times negative 3, j times 3 times negative 1 minus negative 4 times 1, k times 3 times negative 3 minus 2 times 1. And that cross multiplication action is most likely where that cross product name is coming from. So what do we got here? We have two a negative 2 minus 12. We have a negative 3 plus 4. We have a negative 3 minus 2. Now double check that all of your, oh, I found one. The mistakes might be small, but they will make a big difference. And please keep track of your negatives because that is where most of the mistakes happen, is losing track of a negative somewhere. Okay, this looks okay. So I have negative 14i minus j minus 11k. And this is the cross product of these two vectors, v cross w. Okay, let's do it again. W cross v. Let's set up our matrix. I, j, k, w first. 1i minus 3j minus 1k. V is 3i plus 2j minus 4k. So we have I times the determinant of -3, -1, 2, -4, minus j times the determinant of 1, -1, 3, -4, plus k times the determinant of 1, -3, 3, 2. This should give us 12 plus 2, -4 plus 3, 2 plus 9, which is a result of 14i plus j plus 11k. And we can see right away that the order will matter. So v cross w does not equal w cross v. So be very careful that you're aware of what order you're doing these things in. Okay, let's find v cross v. Let's set up I, j, k. We have 3i, 2j, -4k, and we're doing the same vector. So maybe pause now and kind of make a educated guess on what you think is going to happen when we cross the same vector with itself. I times the determinant of 2 and -4, j determinant 3, -4, k and the determinant of 3 and 2. This should give us -8 plus 8, -12 plus 12, 6 minus 6, which is 0. All of those come out to 0. Pretty interesting. Okay, let's double check it with W. We have I, j, k, 1i, -3j, minus 1k. We have the determinant of -3, -1, -3, -1. J is the determinant 1, -1, 1, -1. K with the determinant 1, -3, 1, -3, which will give us 3 minus 3, I, -1 plus 1, j, -3 plus 3k, which is also going to give us 0. All right, find a vector that is orthogonal to u and w. U is -2i plus 5j minus 3k. W is 3i plus 2j plus k. If we want a vector orthogonal to u and w, we're going to find u cross w. And we set that up like we did in the last example, I, j, k. U is negative 2i, 5j, negative 3k. W is 3i, 2j, 1k. Next we find I times the determinant of 5, negative 3, 2, 1. J times the determinant, negative 2, negative 3, 3, 1. K times the determinant, negative 2, 5, 3, 2. So we should get 5 plus 6i, negative 2 plus 9j, negative 4 minus 15k. This will give us 11i minus 7j minus 19k. And this vector is orthogonal to u and w. The way we can check this is by doing the dot product with u and the dot product with w to make sure that they are giving us 0. So let's check it. We'll do u dotted with this vector, 11i minus 7j minus 19k. So u would give us negative 2 times 11, 5 times negative 7, negative 3 times negative 19. So we have negative 22 minus 35 plus 57, which is 0. So that checks out. Then we'll check w dotted with this vector, 11i minus 7j minus 19k. So w gives us 3 times 11, 2 times negative 7, 1 times negative 19, which is 33 minus 14 minus 19, which is 0. And so that does in fact give us a vector that's orthogonal to both u and w. Pretty cool. All right, our last example is finding the area of the parallelogram with the vertices, points 1, 2, 3, 4, and these are their locations. Point 1 is at 0, 0, 0. Point 2 is at 1, 2, 3. Point 3 is at negative 1, 4, 2. And point 4 is at 2, negative 1, 0. I may attempt to draw this for us. All right, so this will be our x, this will be our y, this will be our z. So we have 0, 0, 0. Why don't we plot it with something bright? So there's point 1. Then we've got 1, 2, 3. So 1, 2, and 3. Okay, next we've got negative 1, 4, 2, The 3D is a struggle for me. Maybe there. And then 0.4, 2, -1, 0. Okay, so we've got something maybe like this in our 3 space. And we want to know what's the area of that shape moving through this 3 space. So first, I'm going to say vector u is going to be from point 1 to point 2. So from 1 to 2, and then vector v is from point 1 to point 3. And these vectors, if we wrote out the components, from 1 to 2, then we would have 1 minus 0 I plus 2 minus 0 j plus 3 minus 0 k, which gives us the components I plus 2j plus 3k. And then v, same thing, 1 to 3, we would have -1 minus 0 I, 4 minus 0 k, 2 minus 0. That's not a k, that's a j. That's the k. So this would be -I plus 4j plus 2k. So we have these two vectors, u and v, and if we find u cross v, we would find I, j, k. U is 1, 2, 3, and v is -1, 4, 2. So we've got I times the determinant of 2, 3, 4, 2, j times the determinant of 1, 3, -1, 2, k times the determinant 1, 2, -1, 4. This should give us 4 minus 12i minus 2 plus 3j plus 4 plus 2k. That's -8i minus 5j plus 6k. And we really want an area. So we want the area of this cross product, this u cross v. We want the magnitude of it. Our area is the magnitude of u cross v, which would be the magnitude of this vector we found. So -8 squared plus -5 squared plus 6 squared, and we put that all under the radical. So we've got 64 plus 25 plus 36, which is square root 125, which is 5 root 5. So the area of the parallelogram going through these three spaces is 5 root 5. And it's measuring in whatever units these, whatever scale this is in. So the area, 5 root 5 square units, whatever it is measuring in.